So today, or at least for lesson 10, whenever you get to it, because some people haven't gone to that lesson in their algebra class yet. It's about factoring when A is not 1. So that is what we are doing. We learned how to solve by GCF on Monday. You guys actually learned that before spring break, so hopefully that's like the skill you remember. This I will come around and check, maybe like at 11:40. I'll come around and check this. If I already checked it earlier in algebra, I do not need to check it again unless you did more on it. Which I mean, I encourage you to do, but is it worth the most amount of points of everything? Like, no, but it is like a foundational skill. You need to know how to factor by GCF. Do we have any questions on this practice yet? Yes,
Okay, so you said, if you either just even or odd.
yep, okay. So you would have had 12 problems to do. Yes, plus evens or odds. Really, if you know how to do it, it shouldn't take you longer than like 12 to 15 minutes. That's like a minute per problem. So if that's the struggle, if you find yourself struggling to finish it, then tell me, because it really shouldn't take that long. Do you have any questions on it right now? I want to see an example of it. Okay, if you do later, let me know, but that was like yesterday's lesson. Today's lesson, we did when A is not 1, how to factor it. Here are those steps. So those of you that haven't had the algebra lesson yet, either take a picture of it, take your own notes of it, is what I'd more rather recommend, but these are the steps so that you can get through the lesson 10 practice. So first step is to look for and factor out a GCF when necessary. I'm going to walk you guys through these ones. If you already have me for algebra, this is in the notes. If you want to write it down, I won't force you, but it's like at least 3 to 4 questions on your unit tests. Unit tests are like 150 assessment points, so it's important. But first step is to look for and factor out a GCF when necessary. So look at this one first. Don't tell me what the GCF is, just think about it. Everyone needs to participate. I'm not joking. Hold on, everyone listen. GCF between 15, 18, and 24. Think about it, don't shut it out. Greatest common factor between 15, 18, and 24 is what? 3. Okay, it is 3. Always check if the smallest number is a GCF. It doesn't divide usually into the others, but when you break that down further, you find that it does have a GCF. You need to factor that out. Can I factor out any Y's in this one? So GCF is just 3 for this one. That goes outside parentheses. Inside is what we get from dividing each term by the GCF. So when I divide, I get 5y squared minus 6y minus 8. That's GCF. On Monday's lesson, we were done at that step, but now you have to check the parentheses and see if it's factorable by any of the other ways that I taught you. And today we learned how to factor this. So we're going to apply that. We are going to do the diamond method only for the parentheses. Like the GCF is just going to live out here in our answer. We're not messing with that anymore. We're going to do the diamond method where it's A times C on top, B in the bottom. A is always in front of the x squared, usually is what it is. B is in front of the x term. B is the constant. So A times C, what's 5 times negative 8? Negative 40. Negative 40. What's my B value? Negative 6. What multiplies to the top and adds to the bottom? What are some numbers that multiply to 40? origin. And that could possibly give me a 6 when I add or subtract. Well, it's a -6, so the negative should actually go on the. Okay, so that makes sense? Go with me on that. That's something we've done before. That was your coloring activity. All right, now previously we were done here, but now that X is not X. Now that A is not 1, we have to now continue with these other 2 steps, which is to divide the factors by A. So what was A? That was before the GCF. So after the GCF, A is 5. Okay, GCF is completely separate. It's like leave it in your answer, but we're factoring this part. So yeah, my A is 5. I need to divide both my factors by 5. Reduce the fractions, and then you will slide any remaining denominators in front of the variable. If you do not know how to reduce fractions, that is okay. You can use a calculator for that. All scientific calculators have fraction to decimal buttons, including decimals. If I want to see if 4/5 is fully simplified, I type it in. It'll give me the decimal, but if I press this button, it'll give me the simplified fraction. Okay, so like, I don't know, the -10/5, you can try that one out too. That just ends up reducing to a whole number, but this is how you can reduce your fractions. That's the like, for really where it's built. Anyway, 4/5 is already reduced. -10/5 reduces to -2, so this parentheses will be y-2. I have a remaining denominator over here, though, that needs to be split in front of the variable right there. So this parentheses becomes 5y+4. GCF is still around, like it should still be in my final answer. We just don't really do anything with it after first factor. Okay, does that make sense? You want to see another one? Now listen. I know there are so many ways you could cheat, especially when it comes to factoring, like you could probably find one online, a factoring calculator. But like, who cares if you get 100% on your homework, to be honest? It's only worth 10% of your grade. You need to pass these tests without cheating. So like, please practice how you will test. You could use things like that to check your answers, but like, don't use it as a step 1. All right, but I'll show this one now, the one right next to it. Anyone cares? If you don't care, then work quietly on your stuff that you can get done. But over here, first step is to look for and factor out a GCF when necessary. Is there a GCF between 32, 16, and 2? Okay, good. GCF is 2. When I factor it out, and I can't factor out any variables because they don't all have variables. In my parentheses, I get 16w squared minus 8w plus 1. So any questions on factoring out a GCF? Anyway, just want to get some space. So that's me factoring out a GCF. Use the diamond method now to factor out the parentheses, or at least see if they can be factored out. A times C, 16 times 1 is, and then my B value is what multiplies to 16 and adds to -8. What are some numbers that multiply to 16?
Oh, 4 and 4.
Okay, this could possibly give me a -8 if I do what? Make them both negative. That's how it can multiply to a positive but add to a negative. Okay, Now, the GCF, again, is just gonna live in your answer, don't like do anything with it. My parentheses for right now are this. But I know I'm not done because W times W is not 16W squared, so you have to remember these last two steps that we have to add in. So next I have to divide my factors by A. What was A? Again, don't look at the very original, look at where we started factoring. So divide by A, which is 16. If you don't know how to reduce fractions, I mean, I can teach it to you, but I feel like people's eyes just like glaze over, and I do. So, feel free to use the calculator. -4 over 16. Reduced fraction is -1/4. Okay. That's the new fraction. So I have two parentheses, W minus 1/4. W minus 1/4. Slide any remaining denominators in front of the variable. Once you reduce the fraction. You will have to do that at least once for each of these types of problems. Because that's how you get a different number in terms of the x. And then you could double check your answer, see if when you multiply this all out, does it give you the original? And it would. Okay, so I'll leave this up for a while. But like your to-do list is to take out your GCF practice and just leave it visible. I will check it at around 11 or 5. Then do your lesson 10 practice, 80% or higher. Should be in all the solutions, but let me know if it's not for some reason. Ask questions as you go, but I'll check in it later. But if you don't need help, I just need you to be quiet so that the recording is not tampered with your voice. So number 5 was the one asked about. This one is all about GCF. So first look between the numbers. What's the GCF between 64 and 40? Biggest number you can think of that multiplies to both of them. If that's hard for you to figure out, I suggest making a factor tree, break it down to all its prime factors, which ends up being a bunch of 2's for its prime factors. For 40, I'll do 4 times 10, breaks into 2, 2, and 2, 5. So only look at the prime numbers. I'll even cross out the non-prime numbers so you're not confused. The ones that they have in common, you're gonna identify. So like, they both have 3 2's. And I don't see anything else they have in common. Class, what's 2 times 2 times 2? 8. So my GCF between 64 and 40 is 8. That's how you find the greatest one if it's not clear otherwise. So if you thought 4, if you thought 2, you want the greatest one and it's 8. Can I factor out any variables on this one? I cannot because they both don't have an A and they both don't have a B. It has to be present in all of them if it's going to be factorable for the variables. So for this one, my GCF is just 8. I'm going to divide both terms by my GCF. 64 divided by 8 is -40 AB divided by 8 is, okay, good. And if you need to chunk it and break it up, like do -40 divided by 8 and then work out the variables. But that's my answer for that. Any other questions from the paper? Oh, the paper first, and then I'll come around and check the papers, and then I'll take questions on other things. When Andy comes out. Yes, you can turn it into school, yeah. All right, any other questions from the paper? Okay, so I'm gonna come around and check it briefly. People. But this is number one on the lesson 10 practice, all about factoring when the leading coefficient A is not one. So first thing you should always check for when you're asked to factor is what?
The X squared. Or very common, very.
Okay, good. If there was a flow chart, that would be at the top of your flow chart. Like that's always the first thing you check. Is there a GCF between 11, 17, and 10? There is not. And no X's to factor out because they don't all have an X, so then I move on to step 2. Later on, like in algebra 3-4, you'll have like 3 branches coming off of this. The next way that you factor depends on if you have 2 terms or 3 terms. If it's a 2 term, you check if it's a difference of squares, which we've talked about before, but I don't think I need to talk about it again right now. So just know, like, if it's 2 terms, you see if it's a difference of squares. If it's 3 terms, you use a diamond method, or there's other methods, what they call it, but some variation of this, where you are multiplying the number in the A position by the number in the C position. What's 11 times negative 10? Maybe one of these. Good. And my B is what? I'm looking for 2 numbers that multiply to negative 110 and add to 17. Now I'm just making a list until I can figure it out. If you guys find it though first, we're going. Five between 2. 5 and which one would have to be negative if it adds to a positive? Sorry, which one would happen? The 5 would have to be negative. If it adds to a positive, it would have to be on the smaller number. Ethan? Okay, so then from there, this is my answer so far. However, since A is not 1, I need to continue on with a couple more steps. I need to divide my factors by A. What was A? So I need to divide by 11. If it works out to a whole number, then great. Like here, what's 22 divided by 11? So I can just leave it like that. If it's a fraction, I need to reduce the fraction, and this is already reduced. I can't reduce it anymore. Any remaining denominators, you slide in front of the variable. So I have 11x minus 5. Now that I have that, I should be able to get the right answers. 11x here, and then x there. Questions on that? So questions on any others? Questions? Okay. So to rewrite this in factored form, we listed some pairs of factors of 4x squared. And then use what Jada started to rewrite that into factored form. I'm even gonna ignore what she did, and I'm just gonna factor it, because that's like the skill anyway. Our final answer should be what we get when we factor it. So first thing you should always check for is a GCF. Do I have one in this problem? Yeah, it would have to work for all 3 of them, not just some of them. There isn't one. So no GCF, move on to the next step, which is to factor using your diamond method because it's a 3-term expression. So A times C on top. What's gonna be my A times C? Negative 28. So some people call this the slide and divide method, where you slide it over, multiply it by that. 4 times negative 7. What's my b value? A negative 12. And I need two numbers that multiply to the top and add to the bottom.
7 and 4.
And 4. Does that possibly give me a negative 12 when I add those?
We know who's me.
So it must be a different combination. So whenever I'm struggling to find the numbers, I just start making a list. 14 times 2. Equals 5. So yeah, I'll just make a list. I'll just work down like 1 times the number, if it's divisible by 2, if it's divisible by 3, but yeah. Which one has to be negative? 14. Okay, questions on that part? That's something we've done before. This next part is added in because the A is not 1. What is the A? So you have to divide your factors by A, which is 4. Reduce your fractions. If you don't know how to do that, use a calculator. What does 14 over 4 reduce to?
You be decimal 14.
You don't want to do decimal.
Okay, so 14 4. But you can simplify it.
You can, you have to simplify it. So that's what I'm asking for.
7 over 2.
7 over 2, good.
Good job.
Because 2 goes into both, so yes, and otherwise use a calculator. What does 2 fourths simplify to?
1/2.
Now, any remaining denominators, you slide in front of your variable. So sometimes they call this slide, divide, and slide. You actually have to slide twice. So it's 2x minus 7, 2x plus 1 is our factor form. Let's fill in these blanks. Questions on that though? So they both should start with 2x. I wonder if there's any three answers to this, because there's, I guess, a couple ways you could write it, but I'm gonna write it the way that I wrote it. It is okay if you did the 2x plus 1 first, 2x minus 7 second. Let me make sure that it gives you full credit either way. Looks like it will. All right, any other questions from this practice or any other classes? Fine.
4.
Number 4. Okay. Factor and then solve for all possible x values. So first thing you always check for is what?
The grades 25.
And is there one between 9 and 25?
No.
So then you move on to step 2, which is based on the number of terms, that'll determine how you factor. Over here, I had 2 terms. How do we factor a 2-term expression? Can we do the diamond method with our 2-term expression? You can't. That's only with our 3 terms. So what's the other way we talked about? If it's if it's a 2-term expression, we can only factor it if it is this. What is it? Funding squares. Anyone want to finish that?
Here we go. No, it's like, no,
Okay, it's called the difference of squares. So if it's a 2-term, it has to be a difference of squares in order to factor it. What does difference mean? Is this a subtraction problem?
Yeah.
Okay. Are these perfect squares on each side of the subtraction problem?
Yeah.
So then You apply your difference of squares rule, which is this. You take the square root of each of your perfect squares, and then you set it up like this. So what's the square root of 9x squared? Good, so that should be the start of each parentheses. What's the square root of 25? And the way that this rule works is you have to have the, like, basically the same parentheses, but opposite signs, like this. Now, this isn't my solution, this is my factor form. My solution I get from setting each factor equal to 0 and solving. Okay, questions on that? It just so happens that it's like a two-step in order to solve. So start with what's farther, what's opposite of adding 5. Whatever you go on one side. I get 3x equals -5, opposite of multiplying 3. Do that on both sides. So one of my answers is this. My other answer I get from now working this one out with opposite of -5. There you go on one side. I get 3x equals 5. Opposite of multiplying 3 is whatever you know on side. So that's my other answer. It says it wants it in fraction form, not decimals. That's all it tells you about. Yeah. All right, remember point 12.